Hello.
Hey, Tony. We can hear you.
Yep. Hey, Produce. Hello, Andrew. Long time no talk to.
Hi, yes. I've been traveling a lot lately, so it's been difficult to join.
Yeah, well, welcome back.
Yeah, I'm actually on my phone at the moment, so it's not the best experience, but it's at least I can join.
So we have Mark. Hello, Mark. Boom.
Hello.
Hey, guys.
Hello.
I'm going to ping David and James, see if they're going to be joining.
Hi, everyone. Hello.
Hey, James.
Hi, James.
Hey, it seems that we have number of block share. Let me quickly open up the share my screen and a second here. Oops. Just, why not able to? Okay. Can you see my screen?
Yes.
Yes. Yeah. I think from the previous meeting, so we was talking about review the prototyping that we create example from the demo. So I'm not sure if any chance that this is a demo and then this is the example result that we created based on the material schema that we were using from the OCP demo. So yeah, I wonder if you guys get a chance to look into a review on that, right? Especially I think I've seen Andrew, you are back. It's nice to have you back. So
Yeah, sorry, I've been traveling a lot, so yeah, I can.
yes. So
Fine.
yeah, I'm just wondering if you will be able to get a chance to look into this information and also look into the based on this example, the data that we generated using the schema based on the sorry, just kind of jumping around a little bit. ML, that what we were working on. So that's kind of weird. I think what's the issue. But anyway. Yeah, so if you get a chance to look into that, but and also Michael, I'm not sure you get a chance to look into it as well. I think that's from previously what we talked about. We should review this.
Yeah, we did. We created both the schema for the ADK and the MDK. I'm trying to get in touch with Justin to see if we can get him onto the call here and show you what we've done. But we've already presented it to David 2 weeks ago, and the question we asked for especially on all of the ADK side is, now that we have all the formats set up correctly, we think is correctly, we need to test it out by loading into it a whole bunch of rules. And the rules have to be very specific as to because all we're doing is just the format.
Michael, we're talking about MDKs today, not ADKs.
Yeah, it's the same structures. The schemas are format-wise has been created for the MDKs in with the ADKs, alongside the ADKs, but under the same umbrella. The second thing we suggested is that we suggested to David that he should create a full design so that we can take what's in the both of these design kits and link it to the various elements in the design, just so that we can prove out that when you take one of these design kits that is specific to a component or to the interposer, that the software will be able to recognize it automatically from and attach the right properties file to the right component. So we went through that with David. I was hoping that he'd have gone through that with yourself.
So you say you include also material. Do you include like the material? I mean, like
yeah, this stuff here that you talked about. Yeah.
Okay, and then the structure that is similar that what we have here. I think the schema, or you have a size different or any changes?
It's a different schema. It's not the same as this. It's tied to the rest of the parts that makes up an advanced package. So a material property schema is attached to something, right? It's either attached to the interposer, the substrate, maybe the various components, and you need to have a way to that when you open up that file in isolation, that the software is going to be able to make that mapping to the component that it belongs to. And what you want to minimize is this manual mapping. So I cannot get through to Justin right now to show you, but I suggest that we have a separate meeting to talk about all the design kits with the schemas in one meeting, and so that we can show all of this together and have it as a working session as opposed to just an update.
I'm here, by the way, Michael.
Oh, okay. All right. Just good. So, if
Michael,
do you want?
Are you going to coordinate that meeting?
Okay, I can coordinate that. Won't be next week because we're buried with the JEDIC conference calls all of next week. So the week after.
Okay.
So it seems like you have a separate schema more kind of aligned with the JEDIC, I assume, schema. So yeah, maybe we want to see like this kind of like schema that we have based on ML. We see you can kind of like what you have captured all information here. I think one thing, and I think see like we can also like kind of compatible with what we have here, so you're more in sync that way then. Since we also plan to publish this one under OCP, and then we will just make sure that like is kind of information will be in line. I think like with the JEDIC, that it actually I think like information from what we put in here from the ML can be also kind of like incorporate in that JEDIC then for the information that we plan to support.
You want to publish this ahead of having this working session with that I'm proposing?
No, I think we can work together. I'm just saying like we'll see, because this is really based on ML. I think like starting point probably starting different from yours. Yours is more starting from the JEDIC. So it's assuming there's a structure that you want to combine there. So we kind of more combine to a structure based on ML here. So not exactly the same, but hopefully the structure mostly are similar, so they can be more compatible. Compatible that way. So once later on after that we publish anything that not very compatible, we can kind of try to align that so we can make a notion so that we know like where it fit into on both ends, so that I think like when later we kind of like publish in OCP, there's no conflict with what you publish in the JDEC, and they're not necessarily be the same, but at least they kind of like structurally make sense. I think also like some structure that would into their ML with thing, and especially I think like answers use them, and we see that makes fit and they support certain thing. You want to make sure that what is created also under JDEC also have similar structure, can support similarly there. Right, the graph and things like that.
Yeah.
Okay.
The big question we have on this is a separate file that is delivered along with the part that the properties belong to. How do you ensure that if you were to get, let's say, 10 files for 10 different parts, how do you ensure which file goes to which part?
Yeah, that's a good point. I think we talked about that before. We do incorporate like kind of like the part ID, like NPN or the part number, so that they all should have the same part number, so you can align that even with the version, everything. And then you can have like kind of like the ID for the part also. There should be kind of like align with the part number, like the ID for each part there.
Hang on, guys. I think we're confusing things a little bit. We did say that there may be circumstances where, say, an interposer, possibly even a substrate, could be a part, but in general, they are not parts. So a chiplet is a part. So, we need material properties for the chiplet. So would we assume then that chiplet would include the material properties associated with it?
Well,
or is that a separate file that I would think it is, because otherwise, if you're getting a chiplet from some third-party vendor, you don't know what the material properties are. I mean, it's
right. So
pretty straightforward for silicon, but it may be different, for other substrate. So I don't think that's in the CDK.
So a lot of this stuff, hang on, Tony, you're just jumping too fast. Let's take it in pieces. So for a die, we had already built in this material properties into the part model for the die. So now it seems like the materials property kit that James is showing here is for other things, but not the individual chiplet dies.
Correct. Okay. So there are provisions for the material properties for a die in the part model. I understand that, but technically it's not in our checklist to have those material properties. So that should be added, as something that is it a requirement?
Yeah, I think we should have that. I think for that.
Okay.
Some reason, yes.
Okay.
So that means now you're not having a separate MDK file to the part model file for the chiplet. It's all embedded in the part model file for the chiplet.
That's what we're proposing here. So
okay, well we did that like 2 releases ago, right? So that piece is covered. So the MDK that you're referring to here is specifically to do with the interposer or with the substrate. Is there any other MDK that you're applying here?
I think also on the chiplet, right? This one will be used for the material for the chiplet as well.
No. We just said that's part of the chiplet model.
Why, James, would you split out 2 or 3 elements out of a part model that carries the material property and put it into a separate file, only to link it back to the part model file again? Why do that?
Because like the complete chip, I think I'm not sure how you look into that. You have one the whole thing, like the system that you combine so many chiplets, right? So you can have like that's as one material file. I think that's why makes sense we talk about. I think that including the interposer, everything, all the chiplet on top. But then the individual chiplet that could be when they're not integrated into the system, it can have like standalone material information as well, right?
We're talking about the chiplet chains.
So we're not talking about a system here.
We're talking about a standalone chiplet.
Okay, then there will be one file for that chiplet then.
Right.
Yes.
So the material properties are included in the part model for that chiplet.
So we're not going to have a material for a system, but then we have an interposer, other things like substrate. Then we're going to have like material with that interposer.
Right.
Yes.
So we have it.
All the components that comprise the package will have material properties.
Okay.
With the exception of the chiplet, because that is included in the part model.
So what are all of the other components that goes into an advanced package if you don't include chiplets, interposers, and substrates? What else goes into the package?
Well, I mean, in theory, there could be different substrate types. We can include PCB, right? If for analysis. So
All right. So
Yeah.
so all of those are custom designed according to the advanced package. They're not like commercial off the shelf.
Correct. With, you know, a few caveats like we talked about in the last meeting where Zero ASIC has a standardized interposer for their
Right.
specific chiplet chipset.
Okay. And
But
so one
that's
of
the
the
exception. Yeah.
And so one of the questions we had was that if as the interposer is being designed, is being built up in the regards the stack up and all of that of the interposer, doesn't the material properties change according to the changes in the design?
No, I don't.
No,
think-
they remain static.
Yeah, I mean, why would they change?
I thought the
I
dielectric
mean,
constant.
they may change due to the environmental conditions like temperature or, you know, radiation, whatever environment, but just
But
that
not changed according to the stack up.
yeah, Andrew, would you agree with that statement?
Yeah, the individual layers, the properties of individual layers don't change. Obviously, the properties of the whole stack changes based on the different layers and the different stack ups, but the individual layers don't.
Right.
Right. So
And,
now
and just to add to my previous statement, Michael, sorry, but we could be doing, you know, mechanical stress, in which case you may need to start including some of the mechanical components of the package, like a stiffener or a lid. So there would be material properties associated for that. TIM materials, these are other components that would be part of a, you know, quote unquote 3D IC stack. PCB, you know, that PCB may be sitting on whatever. So I don't think we want to box ourselves into just, you know, stop at the balls of the package, and you know, so we want to include, you know, keep it open so we can extend these simulations as much as necessary, because we need to do those simulations, you know, more system level sort simulations. So there's no reason why we should not include some of these other user definable components, and you know, stiffeners and package lids and TIMs. I think that we should definitely include those. And as long as we have an extensible format, if there's other things we may want to add. Now, there's regulators, there's decoupling caps, there's other kind of component things. We haven't thought about those, but they're gonna need some kind of material properties potentially too. You know, whether they're you know, individual components that are fabricated inside the interposer, or embedded into say, or an organic substrate. So we need to be able to deal with those kind of issues, and have the material properties for those other components that could be embedded in the substrate.
Oh yeah, that sounds good. I agree, because for thermal and stress, it makes sense. So in some of those components, you may not need the material properties to include an electrical description then, because you don't have like wires going through them necessarily, but for the other things you would still want. I agree.
Yeah.
So it sounds like that all of the individual components that goes onto an interposer, they all come with their own part model, with their own materials property inside that part model. Then you have a separate file.
Not necessarily, because if you're going to buy a decoupling cap, that's a part. Yes, you would need a part model for that. But let's say the fab has embedded trench capacitors. That's part of the technology.
Okay, I was going to get to that, Tony.
Okay.
So for all the components that you purchase to put into this package, they all have their part models, and they have their material properties inside that part model. For all the construction work that you're doing, be it the layer stack up of the interposer that Andrew just mentioned there. So let's take that one and break that one down. Andrew said that each individual layer has its own material property, but the accumulation of all of those layers to make up the entirety of that organic substrate, that then can have its own unique material property. So are we talking about the materials that goes into the organic substrate and attaching the property list, material property list to each material part number? Or are we talking about waiting till the design is complete and recomputing the material properties based on the entirety of the organic substrate? Which one are we talking about here?
Not sure I understand your question.
Andrew said every layer that makes up the organic substrate has a common set of material properties. Unless, Andrew, I misunderstood you. But when I assemble them together, then at the complete assembly of the organic substrate, the material properties are different. Could be different. Did I miss?
Well, yes. I mean, I think you're right, but it depends on what you mean by a layer. I mean, if you're thinking about the reinforcement fibers and the resin, that makes up a kind of like a PCB layer, you wouldn't really consider that to be an individual layer. But if you're talking about a adhesive on top of a piece of metal, and I don't quite know the terminology that you use, you consider those two different materials, and it really depends on how the simulation analyst decides to simulate it. Sometimes they will take each of those individual layers and represent them separately. Sometimes they will decide they want to bundle those together, and they will simulate them as one kind of homogenized layer, and they will then calculate those properties. But I think from our point of view, we want to do it as granular level as makes sense. So then it's up to the analyst to decide: do I treat those as individual layers, or do I treat them as a homogenized, set of layers, which I'm going to treat as one material? But that's up to them, and there's different strategies for different physics and for different scales, and probably different individuals may want to do it differently. So I think we would want to keep the properties as individual layers.
So this is the point that we've been making, right, for a while now, and I think we're really hitting the nail on the head here this time around. We need to know how to connect the materials properties file to those decisions that Andrew just talked about that we have to make? Do we connect it at the top level? Do we connect it at the individual level? Somebody has to give us that connection, because a materials file sitting in isolation without its ability to be attached to something, that's the problem.
Yeah. So just, so again, I don't, I'm not fully into your kind of space and your kind of domain. But if we take the equivalent of the mechanical domain, which is more my type of thing, so people would do a design of a component. They would do it in a CAD package, and then they would have a library of materials available to them. And so for each component or each part of that product, they would assign a material to it. Each of those materials would have a ID. And so you might, say you have a component with 10 different parts to it. Maybe 5 of those parts are all made from the same material. So you assign that same material 5 times to 5 different parts. The other 5 parts all have different materials. So you bring in those IDs. So what you end up with is, we call it a bill of materials, a BOM. Basically, each component or each part of that product has an ID associated with it, which is a material ID. You then go to the material library, which has all those IDs, and you can then look up what material that is and what the properties are. Now, now what I don't know is what workflow you go through in your domain, how the EDA tools, how the designer creates it and then assigns those materials, because that's the point where you're linking the materials to the actual component or the part.
So in that description, if we substitute the material for a component, you have a digital twin of that component. So do we have a digital twin of the material? Like when we say we connect this material property to this material ID, this material ID is inside in your library. What is the detail around that material inside in the library? Because now it seems like what we need to be doing is creating a digital twin for that entirety set. What a digital twin for the material, and incorporate into that the materials property, just like we did for the part model. Otherwise, it's just stuck out the side.
Yeah, it's just all the things that all the properties we've talked about over the previous weeks is the information that goes, so that's the digital twin, as you call it.
Is that the only information that you have? Because it looks incredibly small for prescribing material.
Well, I mean, again, we've talked about what's the purpose of this. If it's purely to support simulation, then yes, the list is relatively small of the properties you need. If you want all the information about that material, yes, that list of properties and information you need is a lot longer. And will depend on the type of material it is. But if you're purely thinking of what I want to do, pass the information to allow the thermal analyst or the structural analyst to do his job, then it's a much reduced set of information.
Yeah, and I believe that is the scope of what we're trying to do here. It's to support the analysis.
So the only ID then is just the name of the material, and that's it. And you're going to leave it to a human to make the connection to the relevant material that he has in his life.
Well, again, I don't know how your tools work, but within the mechanical, yes, it's the designer. They use CAD packages and they say, I want to make this bit from this material, and this bit's going to be from this material.
Yeah. So yeah, let's use a more practical example here. Let's talk about an organic interposer, right? An organic interposer is an organic substrate, and then there are redistribution layers, metal layers that are put on the top and potentially the bottom of that substrate, right? And those metal layers, it could be different materials, could be aluminum or copper or some composite. they'll have different thicknesses and they'll have different widths. So for electrical analysis, you definitely need to, and there's dielectrics in between them. So you need the dimensions of that and the dielectric constants. So if you're doing electrical simulations, you really need all those geometries and the separate layers, because in theory that they may be different thicknesses, from layer to layer. In the IC world, typically your topmost layer is thicker. But there's a lot of different variations. So for an electrical kind of analysis, we're going to need that kind of granularity. For mechanical, it's possible if we're going to do a very fine-grained mechanical stress analysis, we might need that granularity. But typically, if you're doing simple warpage analysis, you might want to just have a simplified composite model that includes those end layers, and then you would characterize the mechanical properties of that substrate with layers with some assumed distribution and density of the different layers. So I think we probably need to support potentially different types of models depending on the fidelity of the analysis and the type of analysis.
So where do we get this definition of the information? Because we have
Well, the information needs to come from the supplier, whoever's manufacturing that interposer. So that's going to be the manufacturer of that. So you need to get those material properties from that vendor.
The material property that James just showed a few minutes ago, James, if you can go to that.
Yeah, they came from the vendor.
Yeah, that's and we connect that to an ID, and you just want that in an XML structure, but that XML is going to be manually assigned to a particular material. Like here, for example, material AGC ENA.A1. That's going to be one of the material lists that's inside in this stack up for the interposer. So as long as I have those 4 pieces of data in that, we're good. That's all you're saying. That's the only piece of information we need to have in an XML file is those 4 pieces of data. Because everything else is all design related then, and so it's not coming from a vendor. It comes from the designer.
Correct.
Well, so when he says 4, you mean DKDF, Young's modulus, and CTE?
Yeah.
Well, I mean, no, because as we talked about many weeks and months ago now, for this doesn't include thermal, so it doesn't include the doesn't include the thermal conductivity, doesn't include the specific heat, doesn't include the density. So these are not just the 4 you need. This is just the 4 that you've been supplied with, but you need to find, for instance, you need to know the density if you're going to do a thermal and the specific heat. If you're going to do a transient thermal, you need those 2. If you're going to do a static thermal, you just need the thermal conductivity. So
that's the point I'm making, Andrew.
Yeah, where is that? I mean, do we have that information?
So
what's on the?
Yeah, I mean that's in that like original spreadsheet that that I put together a long time ago now.
Right. Do we have that for this sample design? Is that on page? What's on page 3, James? No. So we don't have the thermal properties here.
So what you're, Andrew, based on the difference of what you described and a full digital twin for that material, is there much of a difference between those 2?
Between the table that James
between
showed.
what? Yeah, between.
Go back to page.
What's on slide 2 versus the full digital twin for a specific material. We take this top material AGC-ENA1. there's 4 elements here. You rattled
Yeah.
off an additional 3 or 4 elements. Is that the full digital twin for the material AGC, E, and A1?
What, again, I'm just going to say that this, that it does depend on the physics, on the type of simulation you want to do.
Yeah.
But like, but so just for the sake of, to answer your question, maybe there's 3 times as many properties. Maybe there's 12 properties that we actually have to decay. There's not hundreds, but
Right.
there could be, 10, maybe 20 properties if you want to support every type of simulation that might come up in, the
Okay.
analysis.
Right. So,
But
so
we're
the
not
way
talking about hundreds.
right. So the way we designed the digital twin for the part model was we did not care about what was the use case that it was going to go to. We said we have to capture inside the digital twin all the information to support any use case that's out there. So we shouldn't be looking at this from a particular use case perspective. We should be looking at it as what does the community want in general? If user A needs it for this use case and user B needs a different set for this other use case, the schema structure should be designed to accommodate both use cases.
Yeah, well, the
All
schema
the-
itself will, because the schema is general, but the properties you put into that schema are specific to what you want to do with that material or that design downstream.
That's
And,
that's
yeah.
fine. That's fine. You can have the software tool downstream pick and choose the properties it wants to
Yes,
have
exactly.
to satisfy itself, but the schema has to be designed to incorporate all of the properties, not just
Mhm.
some of the properties. Now, some of those properties might be mandatory because it's needed for everything, and some of those properties might be optional because it's only needed for 1 or 2 things. But the
Yes.
schema structure is designed to cater for any use case.
Yes, yes. And so, James, I'm James. I don't have access to my computer on my phone, but I did. We put that spreadsheet together where I said these are all the types of, or we worked together, said these are all the types of analysis we probably want to do. These are the properties which are associated with those, with those analysis.
So I remember that discussion. James, have we put that information into our spec?
Let me find that. You mean the spreadsheet, right?
Yeah.
Yeah.
Yes. Yeah.
And I'd be willing, that I believe there's a, is there 1 or 2 other people who here with more of an
Yeah, this
analytic
one, right?
background?
Talking about.
Because
So it's a bit of a matrix. So we have the matrix of the components, right? Interposer, substrate. We created a list for those. And then for each of those components, we also need to define the types of analysis that are supported. And, thermal, mechanical, and electrical.
Is this the one that you're talking about, Andrew?
Yeah.
yes, it is.
This
Yes,
is the one, right?
yes. So you can see that on the left we have the type of analysis. Then there's a subtype of analysis in column B, and then there's the properties in column C, and then D is the type of things which might affect those properties. So frequency, temperature, orientation, wavelength, those kind of things. So if you can, so MatML is very flexible, and this is why I kind of suggest it. It can accept all these in it without any change to the schema. So if then downstream you said, oh, actual fact, there's another type of analysis we want to do with additional properties, it can cope with that.
Yep.
So.
So if I look at the dielectric constant here, you said changes based on frequency and temperature. So that's basically a graph.
Yes, you'd have a set of XY plot. Well, you'd normally have a set of XY points of, temperature, dielectric, strength.
Okay.
And we
you
want to
to
capture that ideally as an equation, right? Or
well, again, that kind of then see column E here is then says these are the kind of thing, these are the kind of models that And if you remember that you then get to then specific tools, require specific types of model or specific formats of data. And then we got in, I don't think we ever resolved that, because then you do start to get quite specific. You have to know downstream what kind of tool you might be using. So
Okay, so-
a kind of cadence tool might use a slightly different type of model to do the same type of analysis as an ANSYS tool.
Right.
And Siemens
Right.
as well.
So that where we draw the line at in JEDEC, we'll say we will not get to a point where we create tool-specific data. We'll create an industry standard format that will contain all the information, and then it's up to the vendors, the EDA vendors, to write a translator from that format into their tool-specific format.
Well, nah, I mean, there may be a different model that requires a different information. So
Yeah, that's fine. You
as long
put
as the schema
take-
can handle that, a custom set of parameters for their tool. That
Yeah.
Yeah,
that's the purpose of the schema. The schema is it takes all the data that is needed to satisfy any software tool, and it puts it into an industry format. This gives the EDA vendors the ability to take whatever data they need to satisfy their model, but it also gives their other EDA vendors the ability to use that same information in a future development of their product. The purpose of the schema is to gather the entirety of all the information that's required by any software tool and put it into an industry standard format. What happens beyond that line is vendor specific.
Okay. One way to separate this out is because when you get to column D, those are column C and D. Those are kind of things which are universal. When you measure, dielectric constant, you do a test, you measure it at certain temperatures and certain frequencies. That kind of data is universal. When you then move on to column E, when you're then starting to fit models to it, that's when it gets tool and vendor specific, because each tool might do it in a slightly different way. But if you give people the basic properties at different, temperatures or whatever, then they can always then do the fitting to that model they want to use downstream, but they've got the basic data which they need to do that. And that basic data, that you're measuring something, that's kind of universal. That's what all these things are based on. So that could be one way that you separate it. You say, look, we're going to give you the properties, and then it's up to you to do the model fitting within the tool of your choice.
Yeah, I have another question now on this content here. So on the first one, dielectric constant, you have a symbol called DK, but for all of the other content, like bulk conductivity, thermal conductivity, specific heat, is there an industry standard format for that?
Not as common as DKDF. I mean, those are really universal. I'm afraid that a lot of the other things, you don't always get a symbol or a code which is universal. E is often used for Young's modulus. Rho is used for density. But often.
So it's not about I guess it is a bit about universal adoption, but it's more important about is there a standard behind the definition of thermal conductivity? And if there is, then does that standard have a particular symbol that it should be associated with?
No, I'm afraid that the material industry is particularly poor at standardization. There are standards to measure it, but there will be dozens of standards to measure it. And when you read data sheets, you will see that they quote the standard that they measure it to. Maybe within this particular domain, semiconductors, the IEEE standards might be more prevalent.
Okay.
But maybe not. That's where my kind of knowledge of your domain you need to find somebody who can say for sure, well, yeah, I mean, this should be the standard that we want everybody to report their, dielectric constant in. This is the way that we want people to measure it. I can't
Okay.
help you with that because that's not my kind of a domain of expertise.
Okay, I have another question now for you. On column F, you have surface roughness. Does surface roughness impact dielectric constant?
This is where you start to get a blur between what is a material property and what's the, say, for instance, if you have a, sometimes properties can be affected by things like surface roughness, but it's not actually the material properties. It's the it's just the effect it has on the measured material properties. And so things like surface roughness can affect the measured properties, and so you have to take it into account. There's a kind of gray line there. What is
It definitely impacts electrical analysis is impacted by
yes, exactly.
Yep.
Right. So we have within our structure the ability to capture a parameter and according to a graph, but we can also have within that structure a test condition. So is surface roughness equal to a test condition that can be applied, can or cannot be applied to dielectric constant? And if it is,
if you had reported DK, you'd probably want to know what the surface roughness was. You could then decide whether it was appropriate to use. Some people might say, look, that's too detailed for me. I'm going to use it anyway because it's better than nothing. Other people, where they're looking at, say very high frequency, where very, very high frequency surface roughness has a much bigger effect. They might say, we're in the kind of high gigahertz here. I need to get myself some data which is at the right surface roughness, or I have to concern myself with it.
All right. Okay, that's fair enough. At least we can. That's easy enough for us to add in. So the next thing I have is all of these parameters that you have, or properties that you have, the units of measures associated with those properties, and the enumerated value list for each of those enumerated properties. We would need to get that as well.
Mm-hmm.
So, like for example, when you talk about orientation, is that enumerated list like north, south, east, west, or is it front, back, up, left, right, top and bottom? What is the enumerated values of an orientation that are applicable to you here?
Yeah. Again, it's unfortunately it's not standardized. When you look at, say, composites, so a PCB, it'll be like 0, 90, 180, 45 degrees. It will do it that way.
And the 0 degrees
metals, they might report it in the roll direction and the cross roll direction, because a lot of these metals are rolled very thinly. And so the properties can change subtly between the direction.
So we need that. Now in the part model, 3 o'clock is considered 0 degrees, and then you rotate in 90 degrees is considered an anti-clockwise rotation. So if you go with degrees here, you have to have a starting point. Where do you consider your starting point?
I don't know where you consider it to be. It'd be I guess you would then have to define that in your kind of model. This is our 0 degree direction, and everything is relative to that.
Okay, and if it's not defined in the model, then we default it to what is defined in the part model, which is at 3 o'clock.
Yeah. I mean, I guess so.
All right. So I think, Andrew, you have a lot of detail behind this stuff. If we get an hour to 90 minutes of your time, we whatever we have left to build on this schema, it'll be just questions and answers that like what we're throwing at you now, and we will build the rest of it on the fly and incorporate all of this. Okay.
Yeah, I mean, is there anyone, that I'm not saying, but I do feel that a lot of this, if you do have anyone who has, similar knowledge to me in your domain, then maybe we could both work on it, because I would welcome some kind of to make sure that what I'm saying here is actually, correct. It's correct in my world, but I do want to make sure that people are, that someone with that kind of other domain knowledge is looking at this as well.
Yeah, Mike, I'll let you know who can represent electrical and mechanical on our site. Just let me know when you set up that meeting.
Yes, because Siemens have
Andrew,
have a similar kind of coverage, don't we? So
yeah, will you drop your email into chat here?
So Michael, you're going to schedule a time for the schema, right? So maybe can we do that together then?
Yeah, we can invite you to it. Yeah.
So we can cover everything. So like together. So we need Andrew in that as well.
Right. So I need I don't have Andrew's email, but I do have yours. So. And Tony, you need to give me the other person that will do it from a Siemens side, so we can capture this.
Yeah, and we should reach out to Rudy for anybody that Cadence wants to add. And Andrew, I don't know if there's anybody at ANSYS that you want to invite.
no, I mean, I think I know, I can do it from the ANSYS point of view.
Okay.
It's just that if you can, if there's people who are particularly in the EDA or the kind of the electronics area, that would they're the one, that's the area where I have least experience. But when it comes to mechanical and thermal, I can cover that. I just don't have a huge amount of experience in that kind of in the electrical area.
All right, so let's take a let's try and schedule it now if we can. So I think next week is just going to be too crazy for me. So the week after, how about in the Tuesday evening after 1 p.m. Chicago time?
Remember, I'm in
on the
UK, so
UK
that's
time.
pretty late for me.
Yeah. Can we use maybe in 2 ways? Can we use this time for doing that? So anyone else like who, I mean, like, yeah, I mean, feel free to join. If not, then they can always, yeah.
So same time on the 5th, the 5th.
Yes. Would that work for you too, Andrew?
This time's actually a bit tricky for me. I mean, if we could push it back an hour.
I cannot.
1 hour is okay for me.
Push it back and then delay it by 1 hour, or delay it by 1 hour. Is that what you're talking about?
Well, I mean, I could either go. I could bring it forward, or I could bring it forward an hour, or I could take it back an hour or two.
I think
that time is 5 o'clock, or it's 5 o'clock for me, which is I have family stuff I need to do, like school pickup and that, so it's always a bit of a challenging time for me. 5 p.m.
One hour earlier is fine, I think, for me. I think an hour later there's another CDX meeting. I think there might be collusion there. I think 1 hour earlier will be better.
I cannot do 1 hour earlier.
How about 2 hours?
I could do 2 hours later, so that would be
2 hours later I can do.
Is that 11 a.m. West Coast time?
Yeah, it will be 7 a.m. in the Pacific. It's okay with me.
2 hours later would be 1 p.m. Chicago time. Just now, this meeting was starting at 11 a.m. Chicago time.
No, I mean,
so that'd be 1 p.m. Chicago time and 11 a.m. West Coast time.
Can we do a 2 hour earlier?
No, I mean, I'm right in between two very important meetings. Don't know if they get delayed or anything.
Can we do it the following week, Michael?
Then you're pushing it out to the 12th.
Yeah.
Yeah, I could do it the following week at this time.
Okay. That would be the ATK.
Well,
meeting.
no, I mean, it's just
Okay,
this
we
time.
can use that
It's
use
just
the
not.
time.
Yeah, but this time of day is just not. That's why I'm on my phone at the moment, because I'm kind of midway
Yeah.
between stuff. So it doesn't matter which week. This time is actually just not. It's just not good for me.
Right.
All right, so does, what about Wednesday, the 11th? Could we do 9 a.m. Pacific? Does that work?
Yeah,
Yeah.
that's good for me.
I no.
What
So
time?
9 a.m. So what time is that? That's
Is it
5.
time right now?
It's the same time as right now.
That's noon Eastern. So how about an hour earlier or an hour later?
Yeah, no. Wednesday, Tuesday the 10th and Wednesday the 11th won't work for me because I have all the whole afternoon. So your mornings I'm busy
Okay.
with planning meetings.
So is that work for you? Right?
All right. So is it necessary to have everybody on the team? Because maybe that's making the things complicated. If it's just a smaller group, would we have more flexibility in choosing a time, and then we can update the team afterwards?
Yeah.
Yeah. We do have a new SIPI, a very senior person that's starting the week of the 9th. So that's why I was suggesting that week.
Okay.
I think we're getting close. 11 any time work for you, Andrew?
I mean, if you could just avoid the slot we're in for this meeting.
Okay, so can we do one
and
on there?
also
So
avoid
8 a.m.,
Wednesday
right?
the 11th and Tuesday the 10th. I also can't do Friday the 13th. But the timing is just to try to avoid this time slot.
What about the Monday?
Monday the 9th.
9th.
Yeah, that's pretty clear.
What time is best for you on Monday the 9th?
Again, just avoid this time slot. Actually, yeah, just avoid this time slot. And then I'm free pretty much.
So if we start at 9 a.m. Chicago time, that would yeah.
That's 3 p.m. Yep, that's fine.
Okay,
Fine
9
by me.
a.m. Chicago time, and if we need to, can we go 90 minutes?
Yeah.
I think 9 a.m. will be too earlier here. I think can we do like 8 a.m.?
But James, can we not just update you on the Thursday afterwards, or do you want to be in the design process?
Yeah, I'd like to be in that. I think I would like to also complete that schema.
All right, guys, let's schedule this offline. Michael, just propose some times. I'll give you the list of the key stakeholders on our side. We need to reach out to Rudy. He should be there, and we're just going to have to find a time that works for everybody. So,
all right, I need to get the.
Most of us are. We're not going to resolve it in this call. So
right, I need to get the emails. I need to get the emails. So make sure I'll type my email in the chat here.
I could send it, but Andrew, just send us all
I will
that work for you over the next 2-3 weeks, and we'll try to work on that because we've got a lot of we want the key contributors, right? That are really the subject matter experts to capture this with Michael. Anybody else I would view as optional, including myself.
Okay.
So we need a thermal person, we need a stress person, we need an electrical person, and Andrew and Michael.
Right, and what about somebody from Cadence? Did we say Mark is going to send somebody or not?
Well, reach out to Rudy.
Okay.
And tell him, we're going to have this meeting, and he can coordinate on his end. So, it's going to take you a week to get this scheduled, to find a time that works for everybody. And we're not going to get everybody, but let's get as many as we can.
Okay.
Okay.
Yeah. If you share the emails, and then I'll send you my availability tomorrow.
Okay, sounds good. Well.
Okay.
All right.
Yeah.
Thanks, everybody.
Thank you.
All right.
Cheers.
Yeah. Thanks.
Yeah, thank you. Bye.
Hello, gentlemen.
Yeah, I keep, Tony, I keep getting scheduled for things I can't miss over the standards meeting that was just when I was interviewing a person, so.
Yeah, yeah, we had a good call today for material design kits, made a lot of progress.
Yeah.
Yeah, and the scheduling process at OCP has been a little bit cumbersome, so I've been struggling.
Well, I can tell you, I'm learning about the scheduling process at UT, and cumbersome is a good word.
Yeah.
Again, I'll start with the bad news, hopefully, so we can go forward with the good news. I mean, I was in a meeting this morning, and they're thinking it's going to be 6 to 8 weeks minimum before they're going to get a contract that folks can sign on. There's still some of the IP language is, you guys aren't going to accept it. Nobody, and let's be honest, nobody's going to accept it. It's 85% fine, but they have a few things, and it's UT people, not Thai, that is causing the issues. Because they're used to doing things a certain way with this within the state of Texas, and we're really trying to educate them that that's not how this is going to work. And we're trying to get clarity around things. So.
Wow.
So this morning they said 6 to 8 weeks.
Wow.
So team Pratush and Tony, my apologies. I just want to say hi to everyone, but I have a personal conflict, so I will not be able to join, but at least I want to say hi.
Okay. No worries.
So thanks very much. I'll catch up with Tony and with Pratush afterwards.
Okay.
Okay.
Thanks, man.
Right.
So we can get clear through that. We can, like I said, we can get the SOW all completely ironed out, and then we can talk about if we need things before the contract. They are open to that letter where they basically say, hey, we understand the situation. We can start. If you guys can, you can provide stuff, and knowing that it's going to be charged, and one of your very first payable milestones, the day the contract sign is to get paid for the stuff that you've been doing over the last, whatever month. That's what they're offering up for folks with this, because it's taking this period of time. I keep trying to tell them, DARPA has these contracts before, and a lot of EDA companies have signed them, and again, and DIBs have signed them before. So why are we trying to start from scratch? Why don't we just start there? But now that UT is a whole nother layer of, and we're trying to get dedicated people. Currently, we don't have dedicated people, so we're sharing with, the literally hundreds of other things UT lawyers are working on, completely unrelated to this. So they're in the process of getting us some dedicated people. So hopefully, maybe that'll speed things up. But anyway, we can still focus on the SOW, and then after we get clarity done with that, we can determine, like in September, if we want to start something. You guys will have to let me know if you can do it with one of those letters of engagement. I think they're calling it something like that.
Mm-hmm.
And or if not, if the answer is no, can't really do anything until we can actually, issue a PO and people can get paid for it, then we'll have to go from there.
Yeah, I think we probably have a little more latitude on installing software, but services, they're going to be pretty rigid about doing any work without a PO.
Yeah, that's why probably what we need is, probably a few of the licenses to get started on a few things anyway.
Right.
Yeah.
Well,
Okay,
yeah.
so did you want to just continue where we were? I kind of went through the document. I added comments to each one of the lines that some of the stuff we already discussed. So I just kind of put what I thought we discussed, and then I just filled out other things. So I don't know if you want to just continue going through that, or
Yeah. Do you have that? Did you send that, or?
yeah.
I can open it.
Okay, why don't you open that,
later.
Pratush? I'm sorry, I didn't see
Yeah.
it. I just
Yeah.
was on
No worries,
vacation last
Tony,
night.
but I think I absorbed it very well, so it will take us not so much time to go over this document.
Okay.
Am I sharing the right screen? What do you see on my screen?
I see a blue flower, and that's our blue.
Yeah, we see your
wavy thing.
desktop.
Yeah.
You see my desktop? Okay, so I need to change to bring the document here. So I went through it, Tim, and I thank you. Actually, it's a very elaborate. And now you see it, right? Yeah.
Yeah. Now we see it.
Right. So Tony, this is the document, and there are some logistical questions. So there are some dates here, and Tim, you're targeting September first week for SOW. Well, we are trying our best, but yeah.
But that just changed from what I just told you. Yeah, because
I know.
from this
Yeah.
meeting. Yeah. So
And that's why I have a smile now on my face.
yeah. Okay.
I don't want to be the one in critical path ever. Anyway, so we are working on it, and target closure date. Yeah, this is shall we try to put a new number here, or just leave
Yeah, I think if we like, let's put Halloween, 10/31 at a month, and let's see. And again, there's a couple other people that are suggesting to the team, hey, there's a better way to do this, and so hopefully they'll get it. But yeah, cumbersome is the right word, Tony.
Okay. Okay.
Yeah, right. And then so this now, do you want to also push this target out? This target first week in September, or?
Well, the SOW budget, I think we could be technically by the end of September for sure. I don't think we're even all that far off. Depending on how, if you guys need clarity, if you need like a hard and fast date, then I might be tough. But if we say, hey, yeah, we realize it's gonna, sometime between now and the end of the year, there will be an official gun start. Go get them, something like that.
So this for our internal team, right? It's I just want to put a date. Let's say I'll say 9/27, whichever Friday I'll pick up.
Yeah,
it's our,
that's good. That's the day after the kickoff from DARPA, the 2 days,
right.
The 2 kickoff dates. So that I would hope we,
Yeah,
because I'm like, for example, I don't mind telling you, I'm pushing them because we're completely done with the SOW with 0 ASIC 1 because they're a small company and they're doing kind of a little finite area of stuff. It's not encompassing. So we're done, and we're like, okay, so what do we do? And we're like, and then so we're trying to push the lawyers to get going.
Yeah.
I see. Yeah. Okay. And then the project start will probably we keep it for 10/1 for now. Let's say this really is logistical. It probably was. I mean, I don't need to participate in the SOW.
Yeah, 10/1 or 11/1 would probably make it. Again, it depends. It all depends on how much you guys are willing, how much we can do without if you're not able to issue a PO.
All right,
So I guess that would be
let's put 10/1 for now.
10/1. Okay. No, but Tony, we are saying 10/31 is the target date for close date for execution of contract. So
yeah, for the whole contract, 10/31 SOW, we can, September.
Okay.
I don't see any reason why we can't end budget at that time.
Yeah,
I think we can be done with that.
Yeah, I think we, if we could at least do software installations and, if we're gonna move forward, PLM, get that ball started. I mean,
right.
If they play hardball, we could always just disable the keys, but I don't see, I have to have that discussion. I can't make that decision, but in theory, I see no reason why we can't start with training and installation.
Right.
But
right.
Services can be a little bit of a different story.
Yeah, that's understood.
Yeah, we may need a letter of intent or something, or
you want to go over all of these details one by one, Tony? So, for example, I mean, at a high level, right? These are there's a lot of guests here in terms of timelines. Tim, I think so. We can probably just leave things as is.
Yeah.
They don't change anyway. They're anyway kick off plus 4 weeks, so they don't change, right? So, Tony, one thing we need to, I mean, we have said we would install 10 EDA license for each tool.
Right.
That's an estimate.
Right.
But we need to have that conversation with Ted Lane internally to see, because he has to absorb all of it, right? So yeah, I don't see big issues, but there could be some software, Tim, where 10 is an overkill, right?
For sure, that is definitely. You know, I was trying to think of it. It's probably going to be closer, to be honest, for the first year. It could easily be, 3 to 5, I would think would be, and there might be, an occasional tool that we might use more, but I would think less than 5 is going to cover 95% of the time.
Yeah. And
I don't know how much that changes from your guys' side, because again, it's on a kind of a pay as you go. So but I guess you have to allow us to get up to X licenses. But if you allow us to get X to 5 or 10, that doesn't change the cost, because it's if we use them, we get charged, right? It comes out of our budget, right?
yeah.
Yeah, we have a lot of different models. So we look, so you want you want the ability to effectively just pay for the number of licenses you need up to 10.
Yeah, but I like you did 10. Like I do agree with Katusha. It's definitely overkill 99% of the time, probably. So 5 would be probably, if that is made. And I guess again, if we need more, we can always come back and talk to, hey,
Right.
or on month 9, and we need this tool, and we have all of our group and all our divs are also using it. So.
Okay.
And the only difference is, remember, we're not the reason why it's probably going to stay low is because we're not going to ask any of the divs who are going to sign up to do any design work to use any tool that whatever they use, we're just going to tell them to do it in that tool that they're comfortable with.
Mhm.
So if they happen to use your tools, great. But if they don't, we're not going to ask them to learn a new tool. That'll be on us when the data comes back in and we have to put it into your tool to do the modeling and with your guys' help and everything like that. That'll be more on us if they're using HSF or something like that instead. Right.
So is this 10 licenses for all of the EDA vendors, or is this just specific to Siemens?
Well, it's specific to you guys because the other people are doing like one of them is giving us, we don't care, again, it's a pay as you go. So as many licenses you need, but I told them the same number. I said most it'll be 5 to 10,
Okay.
We'll cover 99% of the time. But they didn't actually they didn't put a limit on it. They're like, well, if you need more of something, you can. It comes out of the same type of thing. There's a budget, and if we use more of one and less of another, well, then the money comes out of that.
Yeah, I believe that's the model, but I need to we need to
Okay.
discuss it, and then once we understand it, we'll come up with a proposal and then explain it to you to
Okay.
make sure it's the right model. So we haven't had that discussion yet. So
I think the only thing we don't have, Tim, is to add a tool that we don't initially provision for in the pool. So
Yeah, how do we do that? Because we were thinking, because we there's a list of tools. But that was one of the things on the kind of the email. Well, what happens if you have a new tool, or we realize, oh, we forgot one, but we're not using this other tool? Can we should be able to, rebalance, or whatever the term would be. We're not using this tool at all, so let's pull in this other tool.
yeah,
I
think that would be on a yearly basis. So change the contents. It may be to contract, but if we did it on an annual basis, would that work?
Most likely.
Okay.
And I mean, yeah. Again, I guess at any point in time, if something changes and we need to change it, we can. I know it's a pain, but if we needed to come back and reword one specific, and it was it was beneficial for both of us, then I'm sure we can.
because we do have some products that are scheduled like Q3, Q4. We have board members. I don't know if the pricing is finalized yet, but if those are applicable, I would like to have them on the list, right? Rather say, well, if it's not available, by the time we sign the contract, you can't have it. But if it's definitely a committed, new product that, or a lot of cases, there's bundles. We're bundling different tools that have a whole collection of stuff. So,
Yeah.
okay.
Yeah, definitely like the flexibility that if there's a new tool and we want to roll it in, again,
Yeah.
it would be up to us, hey, it costs X amount per license. So if we choose to use it, we're going to have to, we'll have to do our own budgeting of what to use less of, for example, to make sure we can use that tool. But what we would definitely want to have the ability to pull it in.
Yeah.
Okay. All right.
Yeah. Our account manager, Satan, is aware of this exact problem. In fact, he was discussing the same thing with me and this dilemma. So Ted Link, so we'll go back to him. All right. Okay. And then you have 20 to 50 IPLM licenses mentioned here, and we are meeting with, of course, Tony. I think the meeting is very soon.
Yeah, I met with them once, and then I went out to their website, and then they want to come to do a face-to-face in, I think, the first week in September. I was out of office for a few days unexpectedly this week, so I'm a little bit behind on those emails. But yeah, I think we're probably, again, like I said, we're probably going to end up doing two things a little bit until we figure out which way we want to go. But he hasn't given me a quote yet, so so we'll see how that goes. Because we have some money for a software, but we don't. I don't know if we're talking. I have no idea, so I guess I'll find out when they come.
Yeah, well, we want Michael Muncy to be part of that discussion as well. So okay. He's back, I think, on the 26th of August.
Yeah,
I forget.
And I'm gone. I'm gone starting tomorrow to all through the following next week, and then I'll be back so you have that first week in September,
right,
or the second week in September, either one of those. And they were talking about possibly, I think the second week in September maybe coming, but I'll clear that up with them today. Maybe, and Tony, I'll just CC you on that, so you're aware of it.
Yep.
Okay.
So do you have additional funding for this, or you?
Not really, but I have I have a cloud budget, which we're not going to use for the first 6 months.
Okay.
So I plan on using that budget for this, if need be.
Okay. Yeah. Okay.
And then the DE is for Team Center, right, Tony? So,
I'm sorry.
This one. So that was for the IPLM stuff, 2050 license we talked, and then this is, I guess, this is Team Center, right?
Correct.
And so Tim, you said still considering. So should we leave it out of scope for now?
Because I'm not. Because I'm not sure on that. So probably until after they come and they give me the whole spiel. I mean, I went around the website.
Well, Team Center is a Siemens product. That's for product lifecycle management.
Oh, that I don't think we're gonna. I don't think yet. So I would say probably not, because I know Patrick, who's taking care of the fab stuff, he has this other plan that they're going to be using the Odin Institute, which is a thing out of UT. They think they can do things there. They've signed up to do this type of stuff.
Okay.
But
well, you're talking about the manufacturing software.
Yeah, the manufacturing software.
Yeah, PLM is different than that. So there's semiconductor lifecycle management, and then there's the manufacturing software. So you're saying neither of those.
Yeah, I don't believe so. I think So we're talking about for the revision control stuff that we're talking about, and how to take care of all the ITAR and different design environment combinations that we're going to have to support, and definitely IPLM, I think, potentially can service that.
Right. Yeah, the PLM is targeted more if if you're a fabless semi or a semiconductor company and you're developing products, you're going to use a PLM system. It ties into your ERC system, and it's got the business gating processes and all of that stuff. You're really more of a manufacturing center, right? That has a design.
Currently,
So you're not building the products. I mean, you're not selling products, right? So that's really
people come to us and we'll manufacture it for them. Type of thing.
Right. So you just want to make sure you keep track of all the stuff that was delivered, and you have the traceability, and that IPLM will suffice for that. Okay. Okay.
And then coming to EDA/standards. So currently beyond OCP, I mean, we have OCP and JEDEC participation. I was in a NIST workshop last. I virtually attended a NIST workshop related to standards for interfaces. But I mean, does it make sense for us to write down the expectations in terms of, because it's so wide, right? In terms of committees and standard bodies.
To be honest, one of the first things we're going to do, and it's actually one of Andreas's SOW, is to, because again, there's so many, and one of the first meetings we're going to do as EDA working group is just like that. Here's all these things that are out there. Okay, from a group, so he's supposed to put together a questionnaire, like which ones you guys feel are the most important, and we'll ask that, plus to our DIDs and ourselves, and based off that we'll come up to which ones do we think, hey, it's basically been decided, so we're going to go this direction. Here's another one we need to stay involved with, and we'll pick somebody who's going to either already attending that, and then you can come back on a quarterly basis and update the team if anything changes, or whatever, and then, but again, we're going to try to come up with just like you said, there's so many things out there, which ones do we want to focus on, and that'll be, and I want that to be as much as possible as an industry EDA working group decision. And then, like, for example, again, I don't mind telling you, because I'm talking with Synopsys too, and I highlighted, by the way, like the OCP, you are the only person that is not there. Why? Of course, it was silent, and they have their opinions. And I said, well, this is a perfect example of the EDA working group. Right. Okay, let's just say that that opinions of Synopsys stays. And I said, because I explained, well, you're going to have the ability to come to the EDA working group and explain to everybody why you think the OCP standard is lacking, what you think is missing. But okay, when you're done talking, people are going to have their own opinions. And the reality is TIE is not, if the majority of people within that group are saying leaning to the left, we're going to lean to the left with them. Right. And if you're off onto the right, we don't want to leave you out in the cold, but we're going to be focused on what the majority, the majority of people are leaning one direction. We're going to go that way. Right. And now, obviously, we're open to debate, so maybe you can convince other groups to consider that, or maybe different things. So again, they're saying they're open to that, as you know, but that's one area, different reason. They just think there's. And he started to tell me, I said, look, I'm not the right. I'll wait till you have your 10 minutes in front of the EDA working group to tell them why you think it's lacking. Okay. And then
and by the way, ANSYS was on the MDK call today, so they're still actively engaged. Cool.
Yeah. So Tim, in fact, this very well leads to the next number 9, the topic of UCLA and Andrew Kang. We have met with him separately. We are going to meet with him separately. No, nothing hiding from you. We do have a very close relation with him, and so. Again, the response you have is to basically work through the EDA work group, right? That's EDA work.
Yes, I emailed Andrew because I was like, can I tell Siemens that what they're asking for is already they're already signed up to do this. But absolutely, we can, because they're signed up to do the NGMM already. Now, if we want to, so like one of the things, what I talked to Andrew is like, it'd be the same type of thing. But at some point, one of the early EDA working group meetings will, to propose to the group what you're going to be doing first, and solicit input. Oh, if you're going to be doing a tool that does blank, you know, make sure you do A, B, and C, you know, and this is where, you know, so hopefully we can, you know, because they're going to get, they're already signed up to get paid. So, but it's not, we have a directional plan, but he's open to, like, if there's a good input and it fits within the realm of time and people and everything like that, then we can, you know, change that.
Sure.
Or maybe
So basically, right. So I've asked Professor Kang to work with you to set up the working group. I don't know how, when the team will be defined, because probably you need representation from each corresponding organization. There will be a Siemens guy, there will be a Synopsys guy. But I think till we form the work group, and even before the contract is signed, at least start meeting unofficially and start ironing out the proposal part.
Yeah. Yeah, I think especially if folks are willing to meet, you know, 1 hour every, you know, 2 weeks or whatever, whatever works out to be to get things going. Even though the contract's not signed, then we can. And there might be a few people that decide, hey, I can't. There's a couple devs that are saying, hey, until you get pay us, you know, we're not going to be involved. You know, so there's a little bit of that going on. But it's like, I agree. Some of these early meetings, it's just it's just an hour and then maybe you guys getting together on your own and putting on paper, okay, based off of what we heard, we would recommend or choose A, B, and C, or we support this. We don't think this is a good idea, and this is why, whatever. But I think it's going to take a few meetings to kind of, you know, like you said, let's get specifically what we want out of the EDA group. And so I've got, I think we're going to start with like every 2 weeks, and then we'll go to monthly, then we'll go to quarterly. You know, maybe 2 years from now, we don't need to meet all that often. So so as much as needed and as little as needed, as long as the meetings are productive, then we'll start to have them. And I'd like to start those, you know, probably within a month, the first one, if possible.
All right, we'll eagerly wait for that. Yeah.
Okay.
So some of these decisions actually tie into the SOW also, right? What the art model with Professor Khan would be, because he needs. I think we do need to collaborate.
Yeah.
So
anyway,
yeah. So Tim, I haven't discussed you know, this collaboration with Andrew's team with OCP.
I would talk to Andrew first, and then again, I think, and then let Andrew put on, you know, because again, he is an SOW, but they haven't been working on the academics SOWs. They're last out of the priority group, because they're going to have the same issue. So like they're saying, well, let's get the contract done, so all that language completed, and then they'll do it. So we just have their original SOW, so which is kind of like what some of the things. So, but talking with them is no problem. I don't think there's any issues there. It's basically driving towards the same thing. And then if we can figure out to roll some of that work into NGMM, because it's a, you know, value add to the industry, then I think it fits perfectly within the scope and range of what we're trying to achieve. I don't think we're doing anything, you know, against what DARPA asked us to do, and it goes with our original intent also.
Right. Okay. So we do plan on meeting with Andrew next week. Are you okay if we, assuming that Andrew's okay, that we can discuss with OCP management and say we're going to be working in
Yeah.
You're okay with that as part of the
definitely okay. And again, and then maybe with like details of exactly, you know, we say, hey, we're going to look in this realm and that realm, what we can do, and then but the details
we'll keep it high level.
We'll keep it high level. Yeah.
But essentially, you saw the slide I presented, the DAC slide,
yes.
right? That at that level. And
yeah, that'd be perfect, I think.
Okay, perfect. Okay.
I have a question for both of you. Number G, who put this? This is that I got thrown up. Is it you, Tony? Deliver preliminary 3DK data. Test your CDK, test your chiplet models. Tape out plus 12 week.
I'm trying to remember. Let me check my original version.
Yeah, that's why I put all my comments in blue, because I wasn't, because my comment on that, it's like we can have a target, but I'm learning that, you know, things are going to go a little bit slower, especially at first. So you might be saying, hey, we need blank data so we can do A, B, and C. Well, we might not have the actual data. We might have just paper data or information from, you know, dibs of what they think. And then we can, it'll start there. And then over time, we'll get actual manufacturing data.
Yeah, this is, I think, just give me a second. Yeah. So based on our last conversation, I just captured these as assumptions in our statement of work. That's just our baseline schedule. There's nothing cast in stone, but we have to make some assumptions. You know, we have a budget and a timeline, so that's subject to change. But at the end of the day, we have a bucket of hours, so we're just estimating when those will get deployed. You know, we are going to need lead times to make sure, you know, we have time to get the right people lined up and scheduled. So, you know, we can't commit to these numbers until, you know, we have firm dates, and you know, we'll need adequate time to make sure we schedule those resources. But, you know, I see. We'll slide things around, but you know, we do need to make some basic assumptions. So so we'll just use this as a placeholder for now.
Tony, to understand what it means, so tape out of I'm looking at G1 test chiplet models, right? CDK. So tape out here is the tape out of the chiplet itself, and then the chiplet models will be available 12 weeks from the tape out of the chiplet?
No. So so the idea is there are different chiplets that are going to be used in the test chips, right? And eventually in phase 2. Right. So what we want to do for each of those chiplets is create a chiplet design kit. So we'll get all the information regarding those chiplets, all the different design views, and create a CDK. The chiplet design kit.
So it's not it's T0 you're saying, not tape out.
Yeah, T0. T0 is execution
T0.
contract. Oh, okay.
No. Tape out, that was thrown up.
No. That's 0. Everything is based on time 0.
Okay, got it.
And we're assuming that, you know, we wouldn't get anything from the DIBs until 12 weeks into the contract. Right. So, you know, if it's 20 weeks, if it's 8 weeks, whatever it is.
I see now. So it makes sense now, because we need 2 weeks, for example, to code the design rule manual for it to pose that. I see now. Yeah. All right.
No. These are the deliverable. These are milestone dates. So that's when we would start. And it's in the schedule, Pratush.
Yeah. Okay.
So I put a very high level schedule, budgetary schedule with these dates, with these assumed dates. So if you want to change them, we can easily do it. If you don't have better dates, we'll just go with these.
And it's good. So Tim, to read this chart, basically there are 2 things involved, right? Because the test vehicles themselves are only 2 layer. It's not the full 3D system per se. So, right. But as a portion of the circuit, we should definitely be able to test out the 3D-HI workflows using those 2-stack designs, right?
Yeah, that's the plan. And then eventually towards the end of phase 1, we hope they start doing at least some, 4-layer, 2 sandwich interconnects, and then eventually either the combination of the exemplars or we have the Uber test chip, which is going to be multi-layers, and then they have the design challenge, which we assume we're going to be manufacturing, which we assume is going to be some, multi-layer, microsystem. And it should be targeting all the unit processes that we develop in phase 1. We're making that assumption from talking, and then we had the new PI come last week, and he kind of said that was the, at a high level, that's the plan.
Okay.
And again, to clarify, you have 10 test vehicles, but only 2 test chips.
Yeah, so they have in that version of thing that I had to ask you to remove or take away, but it listed they have names, and one, but it's it's targeting this material to that material with this type of bond.
Yeah.
this with or without an interposer, glass, gallium arsenide, whatever. So they have them named and what they're actually targeting. And then we have 2 dedicated test chips that is the Uber test chip, which we plan on being the catch-all, which we're just going to. We won't even really start designing a whole lot of it probably for a year as we go through everything that we're doing, and we'll identify gaps because we plan the Uber test chip to have anything that we can't get off of material that's coming, and or we can't convince the team that's providing the material to make a slight change, to enable this structure or whatever. We'll put that on the Uber test chip, and then Zero ASIC has a digital test chip that they've already got mostly designed, and they'll be providing that. So those are the 2 dedicated test chips that then we have budgeted for.
Right. So for the 10 TVs, that design for the test vehicles, it's a very simple design, of course, probably only with passive. So it's all going to be done by the TI center, right?
Correct. And that's the issue, is like it's going to be, like you said, it's mainly passive. So we need some active. So like already like the one test vehicle is coming from Zero ASIC. So like, for example, what I negotiated with them is they're giving us X amount of space on their test chip to do whatever. I'll say but we is also the EDA working group, because you guys might come up as, hey, I noticed you don't have a structure that does blank. We really need a structure, otherwise we're not going to be able to. Our models aren't going to work well, and that'll be perfectly. And we can, we'll have space. Hopefully, we can add that into the either one of the 2 test vehicles that we do have of all layer control over.
So
the other ones, it's going to be a little bit of.
So you're going to
borrowing and.
Right. Okay, so you're going to do an MPW then? One MPW?
Yes, that's the plan. And then if we have enough, then we could do a wafer. Global Foundry, we talked to Global Foundries. They're giving us a decent price on if we want to do a full wafer, but if not, it'll be an MPW.
Okay, and Global's doing the MPW as well?
Yeah. For most of them, they're doing a few things with Micros in Qorvo, but most of the discussions I've been involved with are with Global Foundries.
Okay.
Right. And so the choice of EDA tools for the dedicated test chips, probably it's really up to Zero ASIC to choose, right? The tools for their test chip design.
What they're going to do on their side, but on our side it'll be our choice. Yeah. So that's where yeah. So if they're doing the design on their network, right? They can do whatever they want, and they just provide us, say, the GDS or whatever. But if we're doing the work, then we will choose. Yeah.
All right.
Okay.
Yeah. So we have an opportunity here to also, in fact, it is an RSOW plan to the test chip design and design, basically, right? We have it included. Okay, moving on. All right. Yeah, there's no DFT for the test chip here, but we should probably, as part of the EDA work group, we need to bring up with Andreas, especially, what is his plan for DFT in his Uber test chip design.
Yeah, because I can already tell you, like, which you guys, they haven't let any of the EDA companies into the exemplar working group meetings yet, because to be honest, they think it'll be a distraction, because they're getting to the details of things that were not in the first proposal. And so they're really, but I keep saying, okay, we really need the EDA folks, even if you're just sitting there listening, and we say, please don't take this sideways, just listen so you can see, you guys will see where they're at, what they're doing. Because I said, eventually the next question is, we have to understand, how are we going to test this? What are the standards? What did you plan for? What don't you have? What can we modify? But they see that as kind of like phase 2 of this. They want to, let's get what are we actually going to do, and what do we have to supply to it? And then we can have those discussions, so they're still working through those.
Yeah. Okay. This, I think I observed well, the expectations around installation training of ADK development.
Yeah, so we like just like you said, Pratish, we want to, you know, maybe you're doing the design, but or more, it's like, okay, we're going to provide here's the review of the structures we have, and here's for digital and RF and all the different strain gauges, all the different things we're planning. And but we would like your guys' design help say, well, looks good, but I don't see blank. How are you going to do this? You know, and then maybe you offer up a suggested structure if it's something that you think is not a proprietary thing. If you think it's a proprietary thing, then you just reach out to me